We're now going to talk about simplifying radicals, what we were kind of hinting at yesterday. So what is a factor? I want you to write down this question. This is something that is multiplied. What is the prime factorization? Prime factorization, especially of an integer, is when it is expressed as a product of primes. And that means that everything is expressed as products of prime numbers. Now those prime numbers can have powers, as we're going to see. Remember, product means multiply. Sum means addition, difference means subtraction, product means multiply. What is the prime factorization of? Okay, we have 54. A couple ways we can do this. I can think about what splits 54. 54 is 9 and 6. 9 I know is 3 to the second power. 6 is 3 times 2, and if I merge that together, it is 3 to the third power times 2, or 2 times 3 to the third power. That is the prime factorization of 54. Go ahead and do 242 by yourself. Pause. Flip ahead if you want. But 242 splits into, if I look at the sum of the digits, well, I see it's an even number, so let's just make it 2 and 121. Up in 121 is 11 squared, and 2 is 2, so I have 2 times 11 squared. 3,000, if I split that up, I know it is 1,003. Then 1,000 could be 110, or if you kind of look at how many times you have a 10, we know it's 10 to the third power, because it's a 1 followed by 3 zeros. But if I kind of split 10 up, I know that 10 is the same thing as 5 times 2. So I have 5 times 2 to the third power, and then I still have 3. And I'd express that as 2 to the third times 3 times 5 to the third if I was going in order. And if I multiply 8 times 3 times 125, I would get 3,000. So those are prime factorizations, and that's going to be helpful when it comes down to simplifying radicals. There are 3 rules for simplifying radicals. We can have no fractions underneath the radical sign, so if I kind of look ahead, that would be number 3 and number 4. No radicals in the denominator. That's similar to number 1. It's the first one, really. We'll kind of see that here in a bit, but if I look ahead, I don't see any real radicals in the denominator, but I do see fractions, and that's going to be part of the number 1. And no radicand has a perfect square factor other than 1. So, as a little warm-up, if I start with number 1, square root of 121, that is 11, and plus or minus stays. So there's actually 2 results there. Square root of 15 squared. Okay, don't do 15 squared. I want you to see this and this as opposite operations. What are the opposite operations we know about? We know that plus and minus are opposites. We know that multiply and divide are opposites. Now we know that squaring and square rooting are opposites. So 15 squared square rooted would just be 15. You should not have to do anything with that. Whenever we take a square root of a number squared, it's just the number itself, with some exceptions. Okay, number 3. I want to kind of remind you that maybe I can split that up into, we still have the negative, radical 64 over radical 625, and that gives me negative 8 over 25. But in number 4, this is going to be a little bit more difficult. Now, if I look at 12 and 75, I might be able to simplify that fraction, so let's try that first. Plus or minus radical 12 divided by 3 is 4, 75 divided by 3 is 25. Oh, and now this is a lot easier. Plus or minus 2 over 5. For number 5, I have 0.09, which we've seen before, that is 9 1/100ths square rooted, and that's just 3/10. If I express that as a decimal, that's 0.3. Number 6, if I simplify the fraction, I would get 4 over 9, still with the radical, and the square root of 4/9 is 2 over 3. Number 7 is the first one that can't be, I can't take a square root. I just can't take a square root of 50. So, what I have to do is split it up into something I can take the square root of. So if I think about 50, I can do this one of two ways. Let's kind of do this the mental way first, where I just think, okay, 50 is 25 times 2. And 25 can be expressed as, I can break that up and make it radical 25 times radical 2, like this. Now, let's not do that just yet. Yeah, I know, I'm erasing. Let's just think, okay, for 25 to come out of there, I have to take its square root. And so I'm going to end up with plus or minus 5, but I still have the square root of 2. You're going to have many analogies, and I think some of the middle schools may have done some of these analogies. And we'll kind of express this here in a bit. The second way to think about this is if I take 50 and I break it up into its prime factorization. 50 is 25 and 2, and 25 is 5 and 5. Or really, I bring that down and I have 5 squared times 2. So if I make this thing become the square root, plus or minus, of 5 squared times 2, and I look back at what was going on with number 2, where I had the square root of 15 squared, I can see that the square root of 5 squared just comes out as 5, leaving behind a radical 2 and keeping the plus or minus from before. Number 8 is radical 120. With radical 120, I need to think, what is a perfect square factor of 120? Now, if you get better at this, you'll think what's the largest perfect square factor, but we don't have to think about the largest one. I just need to break it up into something. Maybe 4 times 30. 4 will come out, square root of 4 is 2, leaving behind a radical 30. Now, all we have to do is decide, are there any perfect square factors of 30 that we haven't considered? 30 can factor into 15 and 2. 15 is 5 and 3. And we don't have any repeated factors, so 2 radical 30 is our simplified answer. Number 9, we already have a coefficient out there of a 3, but the radical 48 has something that I can take out. Maybe if I look kind of at the small numbers, I could take out a 4. So I'm going to break the radical 48 up into a 4, and that would be 4 and 12. But the 12 also has a 4, which means that 4 times 4 was 16. So I'm going to change this to 16 times 3. The more you practice this, the more you'll start to get an idea of what some of the numbers like 48 can become, because you'll see this over and over again. But 16 comes out as 4, and I end up with negative 3 times 4 radical 3. Negative 3 times 4 is negative 12, and leaving behind the radical 3. Alternatively, we could have factored the negative 40 or the 48, done a prime factorization. So if we did divide by 4, and I could make that a 2 and a 2, and made the 12 be a 4 and a 3, and the 4 becomes a 2 and the 2, and I group those together, I have 2 to the 4th power times 3. 2 to the 4th power. How do we take the square root of 2 to the 4th power? Well, the square root of 2 to the 4th power is the number I would multiply by itself to get to 2 to the 4th. And since 2 to the 4th is equal to 2 squared times 2 squared, the square root of 2 to the 4th is 2 squared. So we have negative 3 times 2 squared radical 3, or negative 3 times 4 radical 3, or negative 12 radical 3, which is what we got before. For number 10, I'm looking at radical 24, and a 5 just chilling off there in front of it. 24, I can break up into 4 times 6. 4 can come out as a 2. 2 times 5 is 10. And we have radical 6 left over. That's really the only work that I would require you to show. I want you to circle this so I can see what you have, but you don't need to make it any more complicated than that. Number 11, if I have plus or minus 2, I just kind of keep the plus or minus with the 2 there. But the radical 54 I can split up into 9 and 6. Now, how do I know 9 and 6? Well, 27 is not a perfect square. And 54 divided by 2 would get me 27. But 9 is a perfect square. And when 9 comes out, it comes out as 3. 3 times 2 is 6. So I have plus or minus 6. Then I still have radical 6. Okay. Number 12. 4. Radical. I have 3, a 6, and a 3. 3 plus 6 plus 3 is 12. 12 is divisible by 3. So the whole number has to be divisible by 3. Divide by 3, I get 121. And 121 is a perfect square. Comes out as 11. 4 times 11, radical 3, or 44, radical 3. Number 13. These are already factored. So what we really do when we have a square root is we divide the exponent by 2. Square root of 3 squared gives me a 3. Square root of 2 to the 4th is 2 squared. Square root of 5 squared is 5. And then just multiply that all together. 3 times 4 is 12. 12 times 5 is 70. Or sorry, 60. Number 14. This is a little practice with something that's coming ahead, so I just want you to see it. 96, this is a cubed root. Here's the thing. We're going to go ahead and completely factor 96. I know that's going to be 3 and 32. 32 breaks down into 8 times 4. 8 is 4 times 2. 4 is 2 times 2. And this 4 is 2 times 2. So what we end up with is 2 to the 5th power times 3. So I'm going to rewrite this as the third root of 2 to the 5th power times 3. Well, we're actually going to expand this out just for kicks. I'm going to put 2 times 2 times 2 times 2 times 2 times 3. And this third root means that I'm looking for 3 of them to come out. I'm looking for a cubed root. Cubed root of 8. That's going to come out as a 2, leaving behind with a third root radical this 2 times 2 times 3, which is 12. So that's coming next year, we'll say. But don't worry about that for any sort of test. I'm not going to test you on a third root. I might put a bonus question, though, for those of you that finish these notes. Okay, so the next thing it says, approximate the square root to the nearest tenth. This is practice with the calculator. So now, just for practice, let's try to see if we can break this down and simplify this just a little bit. 612, I know 12 is divisible by 4. So if I want to take 612 and divide it by 4, I get 1, 21, 5, 1, 3. So I get 4 times 153. And 153 breaks down, that's the sum of digits is 9, so I can take that into 9 and 17. And if I do the square root of 4 times 9 times 17, those can come out as 6 radical 17. Now, radical 17 is probably 4 point something, so I expect a number that is like 24.1. That's going to be my guess. Why? Because again, radical 17 is a little bit more than radical 16. So, well, maybe not 24.1. Let's see. Radical 17 would be like, oh, I don't know, 4.1. And 4.1 times 6 would be like 24.6, but maybe a little bit less. I'm going to guess like 24.4. I really don't know. So we're going to put this in the calculator at the start. Let's just put radical, see, that was radical 612. So that's square root of 612. Oops, not square root of 12, square root of 612. Okay, I know. You're like, why is he doing this? Patient. Okay, 612. See, it's not pressing 6. There we go, 612. 24.7. Okay, so I was off. It was actually 24.7. 24.73, but it wants us to round to the nearest tenth, so you're going to put 24.7. Next one. Let's see if we can approximate this one, maybe by doing a little work first. So I get plus or minus, let's make this 78 over 100, which is the same thing as plus or minus radical 78 over radical 100. Radical 78, does that divide by 4? If we check it, we get, nope, 38. That's not going to work. So divide by 2, you get 39. Let's factor 78 real quick. So we get 2 and 39, which is 3 and 13. So none of that works. So I'm really going to end up with plus or minus radical 78 over 10. Now, radical 78 is a little bit less than radical 81. So we could say this is going to be approximately plus or minus 7.8 over 10, because that's, 7.8, or sorry, not 7.8. Radical 81 is 9, so we're going to plus or minus 8.8 over 10, so maybe something like plus or minus 0.88. That's just a guess. Now let's plug it in and see if I'm right. We're going to go square root of 0.78. Control enter. 0.88. I was right. And that was entirely a guess. Now, really what I'm looking for is the skill of you guys plugging it in, so nothing more complicated than that. And we're done.